Hello and once again welcome to Steve's Long Stay Workshop, where things come to be looked at for various reasons. This is a Farnell 30 volt 5 amp power supply, but it doesn't work, which is why it's here. The story behind this, actually, the story is that I went to Goulburn about 2 or 3 weeks ago, as you know, and Andy was working on something on my bench in the corner as well. And he needed a power supply, so George Christofi, is it Graham? Gone. Mr. Christofi gave us this to use. Plugged it in, and nothing happened. Immediately, he dropped the price from £35, which is reasonable for one of these, to £5, which is very reasonable for one of these, considering it's not working. When he said £5, I swooped straight away and said, "Oh, great, thank you, you know." Because at that price, you can't have beaten that much, and besides, I might get a good working price plate of it, which I'll put in place of the small one there, which is the small one there, which all goes up to 1 amp and 15 volts. So this will be a much better unit to use. So first of all, I've got it here, and I'll put it in the system, as it were, and see first of all what it does. Well, first thing you do with anything like this is look and see what it does and what it doesn't do, which is very, very important. Also, by the way, while I'm at it with these, whether it's when you're wiring things to a mains plug, always leave the live as short as you can, because if it chip over it something, a live must come out first, otherwise this thing could be very dangerous, even if it doesn't work. So that's another tip from tip you should know if you this trade, but for beginners it's very, very worth knowing. So yeah, it's not very happy this unit, so we'll have a look and find out why. Light came on, but nothing else at all. As you can see here, the unit's now switched on. That's off, that's on. The voltages are up full, and there's actually nothing on the meters at all. Okay, it could be the meters, it could be something else. So what that we do at this point, therefore, go across it with the AC, with the DC voltmeter, which is here. There you are. That's the DC voltmeter. Negative to positive, and see what we get. Nothing by the looks of it. Okay. 0.07 or 8 volts. That's not really anything like what it should be. Go down to 2 volts. 0.7 volts. That is not what it should be by any stretch of the imagination. With all these up full, therefore, there should be about 30 volts. Let's see what there is, shall we? Again, so that goes onto there like that. That stands up like that, just so you can see it. There we are. And this goes onto here like here, and you get 1.15 volts, and climb is 1.16, 1.17. That's interesting. The deck itself, it seems to be doing rather more. What's that? 2.6 volts to deck that way. Okay, fine. If we therefore take that and put it on there like that and see what we get. Again, nothing. So 1 volt maximum is not anywhere near what it should be. Nothing at all. So obviously something has gone wrong with this. Graham thought it was working. It isn't, and I got it for a fiver as a result. So let's go into this and have a look and see what is going on with it. Because obviously something is, and that's something. It could be something simple. It could be something nasty. At this point, we don't know. The way to find out is to open it up and have a look. Now, this one, judging by the top here, which was certainly in use in 2012, 2013, which is about 10 years ago. So, you know, it was in use up to that point, but since then it's not been. So we need to find out why. And also, again here, it would appear that some certain screws have been gouged, so we'll know. Let's go with that. Now, basically, all this thing does is it takes in 240 volts, 230 volts AC, and puts out the voltage on the meters up to the terminals on the front. That's all it does. So anything which, in batteries, for example, up to 5 volts, you can set up with one of these. That's the idea behind them. So I'll take the top off and we'll have a look inside. With the top finally off, interesting to note, by the way, calibration thing was actually still okay, but obviously not out of date, so it's brand new anyway. But the screws holding it together were different types, so somebody has been here at some point and done something. But here you are. If you look here, you see there's the big transformer, and by God, it is a big transformer. That yeah, big rectifier, capacitors, all the usuals, and also I think also this supplies voltages to other parts of the units as well up here for this lot. So basically, the first thing we do is have a look, have a check, and see what is where. Now this side, of course, it's got that which goes to here, the other one which goes to the switch down here, which is on. Okay. Some sort of sense switch that I think. I don't know much about power supplies, I admit, so I'm going into a windy bit here, but you know, don't worry about that, because of course we'll learn as we go in this trade. Power supply, well, circuit for it, I really don't know, but we can at this point anyway do a few basic checks, which I'm going to do here and now. So first of all, high AC range like that, and we'll start by looking at this here transformer, because it might be so under big rectifier here, therefore one goes onto there like that, all the way around, and yellow is that one there. So if I switch it on like that, we'll see what we get there. 37 volts, so 38 volts, and that seems to be stable. Now I've got again a range and check again. 34.4 volts, okay, again it seems stable. This meter's not calibrated obviously, but it's well enough to know where things are and where things aren't, you know. So things like this, it will do moderately well, so that's okay. Right, now for the bridge rectifier side of it. Now these of course we can pick up here. So that goes on to, I don't know, there maybe. Look at the top one, goes on there, okay, fine. Switch on again and see what there is on the positive here. .8 volts. That looks okay. Now have a quick look and see if it's working at the front there, because it's not. Okay. So we know therefore that the bridge is likely to be okay, and the capacitors again like to be okay, and somebody outside with a dog that's making an awful racket. So they're okay. So off again like that. and we'll check the other two AC voltages on the other side here. So we'll go back to AC like that, and again here we've got the on this side we've got this going up here from here, so we go from there and there, so you know, from wherever. And here of course, which is there and there. Switch on again, and we'll see what we get. Something like, I don't know, there. Without the hold on, thank you very much. It started doing that lately, you know, that meter. It started switching the holes on by itself, so I don't know quite what it's meant to be doing. 60 volts at that, that's not too bad. That looks to be about right. The other two here at the end, I'll just take the power off again while I find a good way to connect those. So it's one on there like that. And we'll look underneath and the other one as well, which is something like there. What's that? Again, I think they're okay, but I'm not 100% sure. I've noticed actually very quickly that there's a fuse on this board here, so we'll very quickly check that while we're here. So that goes onto there. That goes onto there. That seems alright. Okay. So far, so bad as it were. But again, there's nothing at all on the front at all, so something is not right, shall we say. Something is not right. Let's have a look underneath here. No, nothing at all anywhere. So next thing we're going to look at, now usually with things like this, you can either look at all the basics and follow it through, or you can think, before you do that, think, well, first of all, a look, that's got warm, okay, maybe it should, maybe it shouldn't. This board really has a problem, but the two power transistors are back here, and I think these could be our next port of call, because you know, if they fail, there's four actually on this big heatsink at the back here, so I think they might be our next port of call. So if we take the back off here, you get to them, then we should find out exactly why it's doing what it's doing, or in this case not doing what it's not doing. I think at this point the circuit diagram might well be in order, but I'll check these transistors first, because if I can, because four of them, that's a lot. That this, by the way, it might be one of these plus and minus power supplies with earth in the middle, so you know it's certainly possible. So I don't know a right lot about these, so you know I'm filming myself, making film myself here probably, you know, which is nothing new, you know. I think England are playing Wales tonight in the World Cup in Qatar. I don't know how they're going on, and don't have to, because I simply don't care. I simply couldn't give tinker's cuss. You know, there's always in this business a problem with screws, because three came out no problem. The third one, no problem. The fourth one looks like it's going to take a little bit more time. With the back off, there are 4 2N3055s coming out, and they all appear to be the original ones. So I don't know yet whether we're going to change all 4 of those or not. The fuses, by the way, that one's okay because it's doing something. This one is also okay because I've measured it just to make sure. So it's that goes onto there, something like that. So that goes onto there. And there you are. That's okay. So that's one thing, right? Okay. And anyway, then we go with that again, and again we'll make sure nothing's happening at the top there. No, nothing is. At all. Nowhere. The lights are on, but there's nobody's home, as they said. The LED's on, but nothing else. So, yeah. And so, behind it, there's another transistor here. I don't know where it's meant to be, but we'll have a look and see what's on it anyway. 45 volts there, okay, fine. And there's nothing there, and there's nothing there, but plenty there. Okay, so whether that's got a fault on it or not, I don't know. 45 volts seem to be on all these actually. Look at the back here. So obviously that's okay, but is that transistor 40 or is it switching 40 is the next question what we need to ask. So at this point now, I think at this point we need a manual or a circuit at least. So I will hop online, hopefully there'll be one somewhere, and if there is, and I'm quite good at finding these things these days, I'll get it, and we'll have a look together, and we'll see exactly where the fault is likely to be. Wonderful thing, the internet. You can get anything, circuit diagrams, anything, and yes, the manuals for these power supplies are up there. I thought the manuals for those which are basically the same power supply. But simply, that lot there is on this board here. The rest of it isn't. Okay, so now we've got from here we've got the negative, which goes the negative terminal down there, and we've got the positive one which goes up here, but not down terminal directly, because that will simply be a actually doesn't do those. Now this lot here, there's a current sense meter, there's current and voltage controls, everything else there. But we know already that the voltage is on the back here, on these here transistors at the back here, the 2M3055s. And so what I'll do first of all is I'll check from the capacitors here, yeah, I'll check from there and there, yeah, and from there and there, and we'll check the capacitors here to the 8 ports at the back. That's the next thing we check. Okay, so I could do that without the thing plugged in or switched on. Most of it you can actually with these. Basically it's quite an interesting little circuit. So first of all, that goes onto there, and the negative terminal at the front. This should read. It does. Okay, fine. Yeah, there's a capacitor and the diode across the front, so we'll check that as well. Okay, now the other end goes obviously from there to the back here, and that goes to here. As you can see, it doesn't really want to do. Again, the capacity is there, but nothing else. That's charging there. So you know that goes through the resistor, through those transistors on the back. So right, okay. Well, look at the circuit from there. We'll go to the course here and have a look and see if we get anything on this switch here, which we do. Okay. Again, that is so with that off like that, we shall get a signal there. We do, and nothing there. Okay. Okay. Right. So that switch is there. Now, the next thing I'm going to look at is a resistor across them, a very small 0.1 ohm resistor. So I'll look for that, and we'll see if that's okay as well. Again, it goes from the switch here. It's a 0.1 ohm resistor, and it goes to the bases of these capacitors, to these capacitors here, these resistors here, by one each here. So from there we should come out somewhere. We do, yeah, and that goes to oh right, okay, well in that case we go from there and we go to the anodes, to the collectors here, which I think are these pins here. Again, that they all read okay. They might be faulty, but I'm not sure about that just yet. So that goes there. Okay, that's okay. That's okay. Yeah, okay. The bases are all tied together in the unit, as you can see from the circuit here. Forget me something to point with again. There we are. The bases are all tied together, as you can see. So the bases are them all. And also from there, each one of those, apart from that one there, which is also 3055 there, they all go through the resistors. Now, the chances of 5 of them being faulty, it is possible. It is possible. It depends what happened to this power supply. But I think the next thing we do is look for R104. I think it's this here. Nothing. not a lot there either. Let's try that the other way around, shall we? Let's try that the other way around. Okay, something, capacitor or something charging up there. That's that is off now, and so for that reason there should be nothing from there. It's okay to there, but nothing there. Okay, so that's off. So with that switch out of circuit, we'll go and find this here, which is here. So from the switch there, we should get something there. We do. And the other side of it. So that capacitor, that resistor is okay. Okay. And the others are on this unit here at the back, so we'll hang on, what's this here? That capacitor, that transistor okay there. Right, well in that case, I think the next thing we need to do is find out precisely. Next thing we'll do, before I go and take all that look at, is look at how the circuit works, because yes, they might have all gone, quite possible, but want to make sure that we put another 4 in, they won't just go bang straight away. It does happen, believe me, it does. So let's give the new ones the biggest chances we can give them. So the reference voltage is provided by Z4. If we click on the circuit here, Z4 is on this board here. And test point 8 should have 15 volts on it. So let's find test point 8, shall we, and check for its 15 volts. Whether it is on here, or at least where we can pick it up. R1, okay. There's a diode on here as well, which is at the top here, which is here, and this. So if we go there and there, we shall find. Switch that on. There we go. And we'll put that. And we'll come to there, and we'll look at that test point there. Oh, that's interesting. There appears to be nothing there. It's there now. 14.67 and 38.7. Okay, that's it should be 15 volts on this other end on this other end here. Well, it's 14.6. That's, I think that's near enough. Again, I'll put them down a bit like that and see if it changes it. It shouldn't do, but we can check and make sure, can't we? No, it doesn't. 14.6. So that's there. Okay, so that is there. Okay. Now, The 2 and 3 or 5 5s at the back I controlled from VT3, which is pin 4. So one of these here is pin 4. There's pin 4 there. Let's go to the base here. Let's have a look and see what we've got on there. Whichever one of these is the base here. Note, and note. And that's there. Okay, so there's note on that. Okay, that's yeah. So VT4, is it VT3 here? Is at pin 4, which is down here somewhere. VT3, there's VT4. Is that 4 or 3? That's 4, okay, and 3 is that's BT2, that's VT1, that's diode, yeah, and BT3 is this one here. So let's have a quick look and see what we've got around here, shall we? Nothing. Actually, we might better off here actually measuring that against this diode here, so to find out where we can check that. Doesn't seem to have a right lot on that, does it? Right, okay. But it goes down to deck here anyway, so we think that will probably be right. So I'll have a look back here and see if we can find anything on this transistor here. 43.3 volts, okay, fine. 3.3, nothing, and nothing. So I think the first thing we'll do is that's VT3. Now VT3 base should have on it, well, basically the test point, which is also at 0 apparently. The base of that goes to, okay, fine, so from here that has on it 14 volts, 14 volts, thank you very much, yeah, so that's okay, and so therefore VT3 should have on it that minus the 14, and that one is nothing, and that one appears to be something else. 0.2, 0.0, okay, so where's R17 from there? R17. Is it R17? R17, okay, fine, so it should be around here somewhere. There it is, that one there, okay. So one end of that should have on it 14 volts or so. Which it doesn't actually. Oh. Well, this is funny, isn't it? So that's there, okay. Yeah. And R17 is on that line, and that line should be at R17 here, which is this one here. So therefore there should be something on one side of it, if not both sides, and there doesn't appear to be, does there? Because that should go to there, and that should be, that's 14 volts, so that should be 14 volts. It's nothing. That's a look on that side. And doesn't seem to be anything on this side. So therefore, that resistor has either failed or has been killed by the transistor. So we'll take that resistor out and that transistor out and look at them both. How it works is the circuit will stay still for a minute. It compares the voltage on the output, which is at 0 at this point, as we know, the voltage across R12. Now R12 on the circuit here is at the loop. R12 is that's R11, R12, R13, R13. R12, it's there, yeah. It's that one there, yeah. So it compares that voltage with the voltage coming out of it, and that is how it regulates the voltage. Okay. Now then, the second half of R32 is a comparator, and that goes to VT3 up here, which I'm a bit suspicious about. Now, what I want to know is whether VT controls the extra 2N3055 or the 2N3055 controls that. So what I'm going to do is I'm going to, first of all, that resistor is okay, that diode's okay, that resistor we don't know, but that resistor is okay. That resistor takes off here, and it's it should have 0.5 volts in it. It's got nothing on it at all here. Got nothing on there at all. If we can get on the circuit here, it's got that nothing at all there, okay, and that feeds back, and also that is reverse voltage that will go in here. So basically that feed that and that up there. Okay, so I'm going to take that wire off VT, whatever it is here, VT101, and see what happens and see if anything comes back. If it doesn't, then from there I'd be inclined to suspect VT101, although we'll take them both out and check them based on that. But basically the voltage is here but not coming out here, and that goes to circuit. And also if you look at the circuit at the unit with it switched on, I just adjust the camera, you'll see that the overload light is on at all settings here. That overload light is on, so that is something else which we need, something else which we need to look at. You see, it's on. Well, and I found out first of all that all the transistors are okay. This one down here, by the way, is checking okay on all And a simple go no go test with this meter. They're simple to do. Just do that, and basically, what you should see are two downs back to back. That's all all they really are. So that's okay, and these are all okay too. So it's none of those. So the purple wire which I took off goes back to this board here, the board with the VT3 on it. So therefore, from that now, we need to go look at VP3 because R17's okay, R18's okay, and you know, so they're both okay. So this transistor is a faulty or being held off. If it's being held off, then we're into the comparator arrangement here, which basically checks against this resistor here, which does look strange, I admit. So basically, we're looking at this board here now, which is this on the circuit. You know, look at this circuit here. You see everything in between that dotted line there. You see that? Everything in between that dotted line there on the circuit, it's all on this circuit board here. So this is where we're going to look now, again. So, like I said, it's certainly interesting. I'll give it that. But I am heading more and more towards BT3 here, which is a 2N3053. A 2N3053. So the next thing we do is get that one out and have a look at it on the bench and see what it is and what it isn't doing. Because if that one is not right, then you know we found our problem. But if it is, yeah, exactly, yeah, because everything else seems to be okay on this. So at that point, I'm thinking, well, you know, is it this chip which is not marked on the circuit diagram? So we'll look at what it is and try and find one if it comes to that. Also, I'll look again at R12 and RC1 because it could be here too. But something is, BT3 is either faulty or being held off by something. So it's this part of the circuit here, at a guess. So again, looking at BT3, which we've got my finger against it there. Yeah, anything back from it. So we're getting there slowly but surely, or slowly but unsurely, depending on your viewpoint on such things. Right, well, the power to the 2N305s on the back comes from VT3, which is being held off, and the base is low as well at 1.8 volts rather than 2.8 volts, which is probably enough to hold it off. So where's the transistor went something further back, I don't know. So now going back a bit further in the circuit, the knobs here for fine and coarse adjustment are fed from this diode here, which is a test point there, and that's okay. So that lot is okay as well. So CT1, VT2 and all that are okay, but it goes into IC1, and IC1 is UA741. And first of all, let's have a look what happens at pin number 3, because pin number 3 comes off the two knobs, and so we pick that up at somewhere like R8. So we'll look at R8 and we see what's there. Now we know that it will be somewhere between 8.2 volts and 0, So let's have a see. So let's find out what's happening at a junction of R8 and R9. So let's find out where they are and have a little look. So get me this is again because I'm getting old, and have a look again and see where they are. R2, R7, R8. The dial's there, okay. That goes out and comes back in, so it could be anywhere on this circuit, on this board actually, if it's on this board, which it should be judging by that. So R8 and R9. So they are on this circuit somewhere. Do you have this problem as well, by the way? The one part you're trying to find is the one that R8. Here we are, R8, and R9 is there. So it's look at R8, which is just below Z2, which is here. So on again, and let's have a look at R8. Shall we, and see what's there. Not a right lot. Not a right lot there. 2.67 negative there. Well, what I'll turn both these down like that and see what there is at R8 and R9 now. So there's nothing there. There's no there, and there's 0.96 there. Okay, and that must feed onto pin 3. So there go back up to 4 like that, and one end of that should go to where the cap's down here, where the voltage is down here. So R9, and R8, and thank you very much. For me going off at the wrong time, thank you very much. Does yours do that? Okay, that's 466. Okay, the other side of it, minus 2.6 again. Now that's worrying, that, because one side of this varies and the other side doesn't, and that voltage goes to that chip. So is it the chip, I wonder? 4.66. okay, well, I'll take these down again, and we'll leave down again. So it goes there. There's nothing there at all now, and still there's 0.7 there. So obviously it is doing something, but what I don't know. Put it back up again like that, and we'll look again. 165. 2.67 negative. Okay, well, there's a negative line on this actually, because an operational amplifier, which is what these are, they operate on a plus and a negative voltage. And the negative, and what happens is that you can run it off a say a PP3 or something by such a positive divider. So S, if you like, is 4.5 volts, and therefore negative, therefore is minus 4.5 volts. Plus was at 4.5 volts, if you like. I'll show you that. Hang on, I'll get some pictures and I'll show you that. Operational amplifiers for beginners. Operational amplifier is this here. What can I use here then? That there is operational amplifier, and it got two inputs, a positive and negative. One is inverted, one is not, you see. It's comparison like, and it comes out there. That's the same way. Now, to do that, it takes a negative supply and a positive supply, yeah? Now, if you want to run it off of batteries, or something like that, your 9 volt supply, and that is then taken to earth in the middle, like that, and therefore that is minus 4.5 volts, so this is plus 4.5 volts, so that's plus 4.5 and that's minus 4.5, and of course that's how it works. That's basically how an operational amplifier works. They're quite a simple circuit, and very handy thing as well. But yes, the voltages can be a little bit funny on these. Actually, there is actually a diode on these, taking them to deck, so because they come off the can you see that? You see, they come off that diode there. You see, so you see there. There's a negative rail and a positive rail. That's how it works. So that's basically how these work. So there you are. So anyway, let's get back to fault finding. Well, first of all, we need to make sure that that the earth and the negative aren't tied together in any way they shouldn't be. And so, negative sense is linked or not linked to a negative by R103 and a switch underneath here. Now, I put the sense out of circuit here like that. I'll put the sense out of circuit here, so that's not a problem. So if that goes in there like that, now we see like that, you see, like that, just like that, and we should get something down here on the. Go get something down here. We do, okay, so that's okay. So negative sense goes to nowhere else. Now, if we go to the circuit, you see here, like that, you see, negative sense goes nowhere now apart from that. So we can use that as a reference point. So R12 is used to generate the voltage which the voltage is compared against to set the power supply at the right level, and that is 33k. So R12 should be 33k. So on this circuit here, R12, that's one side, and that's the other, which is doesn't here to have a make a noise. So that should be 33k. Let's have a look and make sure it is, shall we? 14k. That should be a lot higher than that. That is R12. It should be a lot higher than that. A lot higher, in fact, because that resistor is meant to. The voltage across that resistor is used to make up what the voltage, which the voltage from the front is compared against by the first comparator circuit here. And so if that's out, everything will be out, and so that is the first place we look. So as you can see the circuit here, nothing on here apart from there, nothing else at all. So we can make sure there's nothing else. Doesn't appear to be, I don't think, no. So we'll check and make sure, but obviously to there it's nothing. But the other side of R12 should be, according to the diagram, 33k. But it doesn't appear to be. It appears to be something rather less. 13.9, 14. I think that's 14k there. I'll check on there. Yeah. So it's not. So it's not actually up at 33 where it should be. Now, looking from there and there on the circuit, there's nothing else on this line at all. Like I said, nothing apart from that capacitor, that resistor. The rest of it, there's nothing on this end at all, or there shouldn't be. So I'll check that first of all and make sure, and then we might possibly have found our problem, which is nice, shall we say, but nice. But what I'll do, I'll take this board out of here again, and we'll check and make sure that there's nothing else funny with it. So where's my little screwdriver? Here it is. Right, so this board now comes off like that. Like that. Come on, off it come. Because this board appears to have the fault on it. Whatever the fault is, it appears to be on this board. So this board is coming out to be looked at elsewhere, like on the bench. So now that comes off there like that, and these come off here, and have it on the bench, and we'll have a closer look, shall we? Now this board is out of circuit, and look at again at R12 and see what it's measuring now. So that goes onto there, and this goes onto here, and see what it measures. 33k. Oh dear. Right, so therefore from that it looks as though something else from outside is getting onto this circuit. Across it, by the way, there's a capacitor and a resistor. The resistor, by the way, is 1k. So again, we'll check and make sure that's okay. Like so. That's okay. These lists are all pretty much bang on, actually, you know. And I'll quickly go across this capacitor as well, because it's a capacitor, and well, we know about capacitors, don't we? So yeah, so that goes onto there like that again, I think. Does it? All these circuits are good because they go up to the light. Yeah, so again, that goes to there like that, and goes to there like that. So that goes to there like that. Sorry, let me get this right. Try and get this right, and go and have a quick look at that capacitor as well, which is probably okay, but best to make sure, isn't it? So I'll take this. That's off there like that. Come on, there you go. Right, and we'll check that capacitor, which is probably okay. Seems to be. Go up a long way and see if it's still okay. Again, it should be. It is. So that cap's okay as well. I think it will be, but always with a check where the capacitor is concerned. So therefore, something else is loading this down somewhere. Whether it's on here, whether it's on these, I don't know. But if we go to 16 here, and that should go at the front, of course. So it should go to sense at the front. So that can go back onto sense at the front there like that. There we go. That's it. Right. Okay. And that should go to a pin here, if I've got it right. Oh, the George of, right, okay, it does, okay, right, that's okay. So that's okay. So that's okay. So therefore, where else would that go? Anywhere it shouldn't, I wonder. I wonder if it goes anywhere where it shouldn't down here. I'll go and have a look. But I still think that the problem is on this board. I really do. Because the thing is though, is that if that's going to sense and that's not going anywhere else, it's not 470 ohms, so it won't be that. And this goes to here, and it doesn't join up here either. So it's a bit of a mystery. Well, a lot of a mystery actually, but mystery to what we like. So let's see what we can find. Well, the positive sense I'll come to, but the negative sense simply goes up here, so and nowhere else. So it seems to be okay as far as I can tell. But you don't know for sure with these things, do you? I noticed one of those captain there goes short circuit. It might have. I don't know. I'll check on that. But again, negative to positive sense. There's no resistance there at all, either way around, and there shouldn't be. Now the positive sense goes to the meter up here, so there should be something between there and here, which there is. This side, there's something there as well, so the meter looks as though it's okay. That's all this sense. So that's all that is basically. It measures, it looks across that resistor there, and the voltage across that is compared to the voltage from the pots on the front and the things on it. That seems to be okay as well, as far as I know. I mean, I'm shooting in the dark in here a bit, I know, but that seems to be okay. Now, looking at the circuit here, and looking at this, the voltage compared to R2, the voltage across R12 and compared with the 8 but turn voltage of the unit. The voltage compressor unit controls VT3 and the regulators. So again, we're going back to VT3, aren't we? So it might be worth having a quick look at that circuit. If it's okay, then it's probably going to be the chip, but because all these resistors do seem to be okay. Again, I'll check these diodes as well, but it looks to me as though IC1 is possibly bad as well, or bad at any rate, but I don't know at this stage. But you know, I'll check all these resistors to make sure. Right, now on this board I've checked all the capacitors, all the resistors, all the diodes. They're all okay, so it's going to be therefore one of the chips, or VT3 or VT4, which are all pretty cheap to obtain. So I'll put on an order for the bits and I'll change it one at a time until it works. So basically the fault is with this board here. Okay. Now then, in that respect, what I'm going to do now is I'm going to put a lot of it back together again. And I'm going to do that so we don't lose anything, and also, you know, so I can put the thing aside until next week when the bits come for it. And then put out the bits again, change the bits, and we'll take it from there. So I'll leave this here for now, part one as it were, and we'll get back to it as soon as possible. So this is Steve Pendlebury, Steve Pendlebury Vintage Radio Repair Workshop, or whatever I've called it, and I'll be back soon to finish this power supply off. And so until then, take care, and I'll see you soon. Bye bye.